Right. Tuning BGP using attribute can be done in two ways. As I said, we can use route map. We can also do without route map. But using without route map is only if I want all the destination to all destination. If I want one single exit, wherever in the network, wherever outside the autonomous system, outside my autonomous system, I want to reach, I want a particular exit, then I can use without route map. With route map, I'll use route map whenever I have a few set of destination or one destination to go via path Y, where the other traffic goes via path X. That's the scenario where I need a route map. Route map is a kind of um, policy based access list, I can say. When X so and so matches, then we apply so and so attributes to it, and then we attach to the neighbor. We'll see that in a detailed way as we get into this chapter. Now this picture explains that we have policy, 60% outgoing, 10% incoming, 75% incoming, 20% outgoing. So these are all what policies. Now to achieve this is what we need attributes. Here is an example of tuning BGP with an attribute called local preference. Local preference, we all know that it is for the whole autonomous system, and this is the command to set local preference. We go under a router BGP, and then we set BGP default local preference. A higher is preferred, the default is 100. Now when you give the higher local preference, that router becomes the exit for all destination from our autonomous system. From not only from this router, from every router in the autonomous system to all destination, this router becomes the exit. Now here is an example, a case study where we understand that configuring local preference globally like this is not sufficient enough to achieve what we are going to see in this case study. This autonomous system with 3 routers, it may even have a 300 router. Let's take it as 3 routers now. These 3 routers wants to reach these 3 destinations. And by default, to go to 172.24 and 172.30, B will be the exit. Why B is the exit? Shortest AS path. And to reach 172.16, A will be the exit. Again, the same reason, shortest AS path. So C has got 2 different gateway, 2 different eBGP to these destinations. Now, let us make it easy. This X router, I call it as MTN Global. And Y router, I call it as French X. So these are the 2 ISPs to which my autonomous system connected. Now, as I said, to reach this 172.30, let's call it as, just for example, Yahoo. And 172.24, let us call it as Facebook. And 172.16, let's call it as YouTube. So only to go YouTube, my autonomous system using MTN Global. Yeah, the reason is shortest AS path. Now, in next page, what they're going to show us is After a study, they understood that 30% of traffic is to the Facebook. 30%. The traffic from this autonomous system, 30% is going to Facebook, and 20% is going to Yahoo, and only 10% is going to YouTube. So what do we see here is an imbalance. The amount of traffic that uses French X is 50%. Whereas to MTN Global it is only 10%. I want to balance this. I want to I want the traffic to be equally load balanced. MTN and French X should take same amount of load. How can we achieve this? To achieve this, all that I need to do is, if I push this 20, then this becomes 30. This will also be 30. So if we can match this destination on A router and set high local preference, before local preference is wait, 0th attribute. We don't want to set wait because we want the entire autonomous system to leave this way if it is going to Yahoo. So we will not use wait. We will use local preference on router A, so that router A will start forwarding all the traffic to Yahoo. In that way I can do load balancing. But this high local preference that I wish to give, like 400, is only for Yahoo, not for Facebook. Facebook should continue going to French X. If I don't use route map, this command will make even the Facebook to go this way. Traffic to Facebook also will start going this way. So again, French X, MTN, Facebook, Yahoo, YouTube. This is 10%. This is 50%, because 20 is to Yahoo and 30 is for Facebook. Our aim is to move this Yahoo traffic to the upstairs via MTN to load balance. So I go to this router and tune local preference. Why should I tune local preference? Because local preference only comes before AS path. Right now, 50% of traffic is going to French X because of AS path attribute, shortest AS path. So we should not think about any other attribute. After AS path comes origin, code, MAD, and so on. We should not think about those attributes. Why? Because here the decisions are made based on AS path. If you want to change it, we need to do some changes to the attribute before AS path. So the best attribute to tune is local preference. So on router A, I'm learning Yahoo from X. Also from Y, I'm learning Yahoo. the entire autonomous system is taking French X, meaning Y. It is because of shortest AS path. To override this, I'm going to tune an attribute which is before AS path. In the sequence, if you remember, first attribute is weight, second attribute is local preference. So what I'll do is here, I'll write an access list and match 172.30.00, which is Yahoo, coming from X. Match Yahoo. If the match happens, as the update comes from X, if the match happens to 172.30, set local preference 400. When I do that, router A will inform everyone that for Yahoo I am 400. So all the routers will start using A as the exit. That's the idea, that's the plan. Did you get what I said so far?
Yeah.
Completely or little? Let's see configuration, then you will get that confirmation, that confident. This is what we have discussed so far. By default now, 172.16 is going via MTN. This 192.168 is MTN. And 172.24 and 172.30 is going via French X. This is French X. French X. It is all because of the AS path, smaller, shortest AS path. And this is the discussion we have made. Like after a study, they understood 30 plus 20 is going via French X. 30 plus 20 is going via French X, which is 50%. And this is only 10%. We need to do load balance. For that, this is the solution. This is that Yahoo. 170-30 is Yahoo. Yeah, 170-30. So we write an access list, and then route map. See, route map, as the word says, it is to map the route to a particular direction. Not only in BGP, we can use this route map with OSPF, EIGRP, RIP, static route, all policy-based routing, PBR. Route map will come into picture. So route map, we give a name. This is a name, local preference. I prefer giving names in capital letter because this sometimes will confuse people. Now, this is a name. This permit, even if you don't say, it is okay because the default is permit. And this number 10, sequence number, even if you don't say, it is okay. So this is what important. We have to say this and hit enter. And call the access list and set 400 for Yahoo. Now,
What is this access list? Because currently when I'm working, I can see the prefix list.
anything is okay. Your wish. You can use access list or prefix list, whichever you're convenient. Both are going to match some traffic. Access list and prefix list, they do the same job, but prefix list is allowing you to use that slash notation. You can say slash greater than, less than. You can say greater than or equal to, less than. Those operations are not here in access list. We have in prefix list. So people who are from that operator's background, who knows that and R, XR, all the stuff, they will be comfortable using prefix list. Because you have a lot of and or equal to a lot of options there in prefix list. I love both, but most of the network guys are comfortable with access list, and we can use prefix list in the same place. It's your wish. I'll do one thing. When I do the lab, I'll not use access list because you already see a sample of access list here. I'll use prefix list in the same place. We can use anything. Both are same. Now, we have a route map already written. Then why are we writing another route map with the same name? It is because in this route map, we match only this network. But we will be learning many other networks from this one. Who is this? This is MTN. This is MTN's address. We are configuring this on router A, and this is MTN's address. We say when an update comes from MTN, if Yahoo update is coming, set 400. But MTN will be advertising other networks as well, YouTube and many other networks. For those networks, we do not want to have any local preference set. We want to receive it as it is. So we have to write this. I repeat, all those networks that are not matched here will be accepted here as it is.
We accepting here, but not going to use that as a preferable path to reach those destinations.
Correct. We want to accept the update as it is without any any attribute set. We want to receive as it is. Only the change that we want to make is for this network. So when I write this one, the other updates are also received like before without any alteration. Alteration is done only to this one with local preference. If I fail to give this, only this will be accepted with 400. All the other updates won't be learned. The other updates coming from MTN, router A won't learn it. Router A won't learn it because router A has not accepted it. It's like an access list. When you write access list, do you have an implicit deny? Yes. To override that, what do? We say permit any. You remember?
Yeah.
So that all other will be permitted. If not, there is an implicit deny denying other source in access list. Here likewise, if you don't put this one, MTN is giving Yahoo, YouTube, Facebook. Now you said match Yahoo and set 400, but you have not said about this. So what router A will do when MTN advertises this 3, it will ignore these 2 and accept only this because you have spoken only about this Yahoo. When I write this, what I mean is all the rest should be accepted without any change. You understand that?
Yeah.
So we should always remember to write this route map with the same name, and this 20 is necessary. We have to give any number after 10. 10 is default. Even if I don't give this, it is okay when I create. The default is permit. The very first sequence number by default it will give is 10. But when you write another route map with the same name, it's the same route map. It's not another route map. It's the same route map with sequence number next to the previous one. That is to say that all the rest need to be permitted as usual. Okay, now what we do, we go under the neighbor.
இப்போ இதுல எக்ஸாம்பிள் நமக்கு இதுல ஸ்பெசிஃபிக்கா இந்த நெட்வொர்க் வந்து ப்ரிஃபரபிள் பாத்துக்காக நம்ம 400 கொடுக்குறோம். ஸோ இதை வந்து ரீச் பண்ணுங்க. இன்னும் ஒரு சில 10 நெட்வொர்க்ஸ் அந்த மாதிரி இருக்குன்னு வச்சுக்கோங்க. அது வந்து 5 மட்டும் நான் அக்செப்ட் பண்ணணும், மிச்சம் 5 அக்செப்ட் பண்ணணும்னா அதுக்கு ஒரு ஆக்சஸ் லிஸ்ட் எழுதிட்டு நம்ம 20 ஃபார் எக்ஸாம்பிள் ஆக்சஸ் லிஸ்ட் 66 சொல்லிட்டு அதுல வந்து என்னென்ன ஒரு 5 நெட்வொர்க் அக்செப்ட் பண்ணணும், ரிமைனிங் எனக்கு வேண்டாம் அப்படின்னு சொல்லிட்டு அக்செப்ட் பண்ணணும்னா அந்த 5 வந்து கீழே எழுதலாம்.
Yes. No, you can put deny here. You can put deny here. Deny here. Deny and then say match IP address 66. All that matches there will be denied. And then write another one if you want all others to be received. See, this you want to receive with 400 and you want a few other networks to be denied and few others to be accepted without any additional changes. So then you need third one also. Yeah. So that's how we use route map. Okay. So route map makes this access list more optional oriented. You see, in access list I cannot set local preference. I can only say permit or deny. But now, along with the access list, I can set BGP's attribute. I can set OSPF metric. I can set EIGRP's composite value. I can also say next hop. I can also say hop count. Route map is used with all protocols, all routing protocols. Now, after you do this one, see how the output changes. Only for that network, Yahoo, you got 400 set to MTN. This is MTN's address. Even though the path is long, it is preferred. Why? Before AS path comes local preference. Yeah? You understand this?
Yes.
Now the load is shared. Yeah, load sharing is done. Okay, so this is an example configuration. We are going to do similar configuration in our lab.